job done, and how do I stay current and all this stuff. And the expectations to kind of be an expert on all these things that in some cases didn't even exist 2 years ago can be overwhelming. You know, also hear from people that say, you know, my company now is depending on these systems not just to run the business, but also to really drive revenue. So the pressure to build great systems is on. And then obviously no one wants to get hacked. And we all live in a security world right now where I think everyone's paranoid rightly about that. And it's sort of both the opportunity to use all that tech and then also some of these concerns that I think tries to shape a little bit of how we build Azure. And you know, throughout the presentation today, hopefully you'll see kind of reflected through all the demos and then all the different services that we build, a couple of different kind of points that we really emphasize and really try to focus on when we build the product. And that is, how do we provide an experience that lets you use, you know, the bleeding edge technology, that lets you use any language, any operating system, target any device. And at the same time, how do we provide an experience that lets you be productive doing that? And so you'll see throughout the demos, you know, a lot of focus around how do we provide sort of an end-to-end experience, both around the management tools as well as the development tools. It doesn't force you to do things a certain way, but at the same time helps give you the ability so that you're not having to take all the raw Lego pieces and always have to put them together, and instead actually get something that sort of works out of the box and is sort of designed to handle most cases without you having to have a PhD in that particular topic. We're focusing a lot also in terms of, you know, how do you enable you to use all this tech everywhere, not just inside our data centers in the public cloud, but also inside your own data centers. How do you leverage your existing applications, tools, and investments? And how do you kind of enable hybrid cloud so that you can basically use all this with maximum flexibility? You're going to see, especially in the AI section, how we're trying to build intelligence into the product and provide a bunch of built-in AI that we can give you. Things like security monitoring, things like security threat detection, things like profile tuning automatically. And then also, how do you basically take advantage of AI algorithms we build and also build your own so that you can also make your applications even richer. And some cool demos will kind of walk through capabilities there that we have. And then last but not least, how do we provide a trusted environment? One that's secure, and then also one that meets the compliance boundaries that you need in order to build solutions that can target anything, whether it's healthcare, whether it's financial services, whether it's in different countries or different industries. And that trust aspect is something that we spend a lot of time focusing on. So I mentioned on the tooling experience, you know, one of the things we're trying to do on the productivity side is this focus on kind of end-to-end and try to really think through how do we not just have features, but try to stitch these features together into solutions. And again, one of the things you'll see throughout all the demos is sort of our end-to-end management experience that we focus on. And what I thought I'd do is actually escape out of PowerPoint here and kick off the day and actually walk through a little bit of what I mean by that sort of end-to-end experience, focusing at the beginning on the management experience, since that's sort of cross-cutting throughout all the different services that we'll dive deeper in and write code against later today. And so what I'm going to do here is just basically, I brought up here our Azure Management Console. And so this is a browser-based experience that runs, that we often call the portal, that basically gives you a way that you can sort of see all the resources that you've deployed inside Azure, and basically gives you a way we can manage them. And so for example, if I want to see all my virtual machines, I can click this left-hand nav here, and this will list all the different virtual machines currently running inside my account. I can click on any of them to manage. The other thing you can do is you can do what's called pinning a resource to the dashboard. And so anywhere in the portal, there's this little pin button. And when you do that, you know, that'll create an icon that'll show up on your main dashboard like you have here. And so if I want to click on a particular resource that I use popularly, it's often nice to be able to pin it in order to have it basically be displayed. Now we're going to focus mostly today on applications, and so we're going to focus on some of the more higher level services that we as developers want to be able to take advantage of in the cloud. But I thought I'd actually spend this first demo walking through some of the infrastructure capabilities that we also have in Azure, just to also kind of orient you in terms of the capabilities they have there. One of the things that's cool about Azure now is just the number of different types of virtual machines and raw infrastructure elements that you can build on. And all those higher level services, data, app services, container services layer on top of those, and so they benefit from those as well. a couple of years ago, a big machine in the cloud was like a 8-core system with 128 gigs of RAM. I remember there was a time when that was considered big. Now we've got to the point where you can run inside Azure systems that are upwards of 20 terabytes of RAM and over 750 CPU cores. That's really big. And who knows where we'll be in 2 years from now. And that gives you kind of a tremendous amount of flexibility. What's the biggest machine that anyone here has actually ever used today? Not just in Azure, but just in ever. 2 cores. 900, okay, 900 cores. 900, what's it? Okay, that's a lot, okay, good. We have 900. Anyone beat 900? Cool. Well, this machine here I'm just going to show you is one of our more recent series of VMs. It's called our M series. And like all VMs, when you open it up, you get kind of standard monitoring diagnostics here, and we'll look a little bit later on how you can do more advanced monitoring. This one's pretty cool. It's got basically 128 CPU cores and 4 terabytes of RAM. And it's got some wickedly fast local SSD drives. And so it's a fairly big machine, and what's nice is it's just a VM, so you can go into the portal, you can say deploy, in a minute or two you can log in, and you can do whatever you want with it, and if you just want the kick of saying, hey, I deployed a 4 terabyte VM, you can also hit delete a minute later, and it costs you basically close to nothing. And so this ability to spin up and spin down of any size is pretty cool. When you're in Azure for a VM, you can click the connect button if it's Windows, or you can SSH in if it's Linux. And so this is that VM right here with all these 128 cores, mostly sitting idle, and you can kind of see on the task manager. Again, a lot of RAM that you can take advantage of. One of the cool things we now have with our latest VM families, this is true not just for the M series, but also for the latest D and H series, which is probably more common in terms of usage, is also what's called nested virtualization. And so for this particular VM that's got 4 terabytes of RAM, you might not be able to see it, but basically I'm running right now a virtualization inside the VM using Hyper-V, and I have 2 other VMs running that are both about half a terabyte in size. And so if I actually double click on this, I'm now launching into, we will not patch my system live. I'm now running into another VM that has, I think 64 cores, or 32 cores, and again, half a terabyte of RAM. And then this particular VM, just for kicks, is also running a virtualization system. And so I can actually double click into a Linux VM that is running inside that Windows VM, which is running inside yet another VM, which is running inside Azure. And so you can kind of, you can spend the next 5 hours just sort of Inception-like going deeper and deeper. But that would be kind of like a dream. But anyway, it gives you kind of a sense of some of the power and flexibility that you can now take advantage of, with the cloud. And those types of things, whether it's nested virtualization or whether it's giant CPUs or memory, the good news is they're literally just sort of a click away in terms of being able to take advantage of. And you might ask, why in the world would you want nested virtualization? Which is a good question. There are actually lots of use cases. From an infrastructure perspective. A little bit later on when we talk about containers, you'll also see more benefits for them because it means that we can actually now deploy, say, a cluster of containers across multiple servers. We can now isolate each container in its own Hyper-V boundary. So we can actually do physical memory as well as security isolation between the containers within our apps. And that is taking advantage of that raw nested virtualization capability at the infrastructure level. So all the things you can do in terms of as you manage VMs. Let's go look at another VM here. And again, this is true for all the different sort of VMs that we provide. Is basically do other common management tasks. So for example, I could click on the networking thing here on the left-hand side, and I can basically look at all of the different security groups and rules that have basically been set up to basically control whether or not who can access this particular VM, and how do I basically block or deny individual ports. I can manage the disks and all the kind of standard stuff that you'd expect that we've had in Azure for a while. The other thing that we've then done, going back to kind of that productivity aspect that we focused on, is try to go beyond just sort of managing a VM in terms of the basics of networking and storage and so forth, and really kind of focus on, again, some of the more of these end-to-end scenarios. And so we know that anyone that deploys applications or solutions, if they're important ones, needs to think about backup, needs to think about DR, needs to think about patching and making sure that things are kept up to date and compliant, and needs to be able to monitor their infrastructure to make sure things are performing well. And so we now have built into kind of all of our infrastructure and VM services, these kind of core scenarios directly as part of the management experience. So for example, if I wanted to see, are my systems patched? In this case, because of from an infrastructure perspective, I could basically click on these update management, and this is now querying an agent running inside the VM. This works for both Linux and Windows, and is actually checking to see, are all of the OS patches applied, and is this system completely up to date? And so you can see here, I'm mostly up to date, so all the core OS patches are there, but my anti-malware definitions need some updating. And so again, that's now directly integrated into the Azure experience, and easy for me to monitor. I can also go ahead and monitor all the VMs across my subscription. So in this case here, I'm now querying across all the different VM systems, and you can see, I actually have a couple of VMs that I have not fully patched, and I need to basically drill in and understand what those patches are. And again, that's now easy to basically be able to see. And you'll notice, again, you can do it across Windows and Linux. So this isn't just sort of a Windows-based thing. We have this sort of management experience that can do patching and updating across all of them. And then the other thing you might notice is you can actually do this not just for systems that are running inside Azure, but you can now actually also point to servers that are running in your existing on-prem environment, whether it's running on VMware or Hyper-V or bare metal. You can even point to other VMs and other cloud providers like Amazon and add them into this experience as well, and now do patch and overall update management across your entire fleet of systems. That's something that no other cloud provider does. Other things you can do, which is sort of important, again, when you're managing infrastructure that your apps might be running on top of, is be able to understand what is actually running in your environment and across all your different systems. I think a lot of people, I've seen with a lot of the WannaCry and some of these security threats that have come out, where people are, the first question when they hear that there's a bad security vulnerability is, do I need to worry about that? I don't even know if I'm running this particular component or I have this particular framework installed. How do I actually even know what, across potentially thousands of systems inside my organization, is potentially at risk? And so the inventory capability, again, is now built into every VM. I can actually see all of the system updates on my machine, and more importantly, I can actually manage it across multiple machines. And so in this case here, this is actually showing me every OS, every version of the OS across all my systems. And so I can actually see exactly what version of that particular OS am I running. But more importantly than just seeing the OS, I can even go ahead and look at, for example, what files are on the system. What software is installed inside those VMs? What does the registry keys look like in any of those VMs? And I can even on the Linux side see what Linux daemons are actually running inside there. And so if I wanted to see, hey, is anyone running Apache HTTPD? I can basically search, nope, no one's running that, okay. What about apps for updates with my Ubuntu system? Ooh, I've got an app daily upgrade, it's stopped. I can actually drill into that particular VM and understand who stopped it, why is it stopped, and the full analytics in terms of what it's doing. And again, that works for all the systems that are running inside Azure, but you can also say add a non-Azure computer running on-premise, running a different cloud, and integrate this into that experience as well. Question? Can you speak up a little bit? Sorry. Yes, the question is, do we capture history for audit purposes? Yes, we can do capture history of audit purposes, and since you asked, let's go even further, which is not just the sort of audit logs, but can we do change tracking in terms of even differencing of different values and things like that. And that's what this next item on the list looks like, called change tracking. And so what you can do there is change tracking, not just across Azure. So we do have a full audit log that we also expose in Azure, but we can even look inside the VMs and provide change tracking, audit tracking for what's going on inside the actual apps and infrastructure as well. You've got to turn it on, but once you do that, we'll capture that as well. And so in this case here, again, across both my Windows and my Linux VMs, I can actually see all events, all files, all registry changes that are occurring. Let's do it across the fleet. So you can see here, in the last 24 hours, I've had 453 events that have occurred, 8 daemons that have launched, no registry changes, and then I can also look at software updates. And so if I wanted to see, for example, what's a good example to look at? This file was changed. I can actually drill in here and see when was it modified, what was the checksum before and after, and then also even get down to who was the owner and or the person who modified it and how did they modify it. And so that also is sort of all built in. I can do that for Windows registry settings, I can do that for Linux config files, I can do that for OS changes as well as just applications as well. And again, it's all searchable. It works, again, everything across Azure, Linux and Windows, but also against your on-prem investments that you already have as well. Again, all integrated as part of that experience. Yeah, another question.
Can you give this information on sort of like an event-driven basis, or notify me when such happens?
Yeah, great question. The question is, can you get this on an event-driven basis? So instead of having kind of notice search, can you be notified if something changed? Yeah, you can, and I'll show you this afternoon in sort of the tips and tricks talk, or so the part 3 talk, how to set up alerts. And so we now have inside Azure the ability to trigger alerts pretty much on any threshold. Meaning, you can basically fire on a whole bunch of different conditions, and then we can email it to you, you can SMS it to you, you can do a webhook, so you can do whatever custom code, and we'll talk later about using serverless code with webhooks. And you can do event grid, and we also now also have ITSM integrators. And so if you use ServiceNow or BMC or another kind of existing ITSM system across your enterprise, we have a direct connector for those that you can plug in. And we're even getting to, today you can do it with a webhook, and we got some sample code how to do it. But we'll also have it so that when you wire up an alert, you can literally just say, pump it into my Slack channel or my Microsoft Teams room. And so when you get to DevOps, you can actually have everyone that's monitoring or working on a project actually see, oh, Joe just deleted the database. And you go like, why did Joe do that? And you can integrate it with whatever channel you want. We'll also talk in the afternoon about role-based access control, which is a great tip and trick, and that can prevent Joe from deleting the database. As well as a new capability that we have inside Azure called policies, which allow you to not only monitor what people are doing and or lock down what people are doing, but you can also set policies so that you can say, you can't do this. So that gives you a way that you can say, you can't deploy a VM unless it has encrypted disks. You can't deploy a VM unless it has malware turned on. You can't deploy a VM if it has management ports open to the internet. And that gives you kind of an additional capability where not only can we tell you when you're making a mistake, but we can actually allow you to enforce policy so you can't make that mistake. And then last but not least, I think especially this past 6 weeks, we've all experienced Mother Nature and the power of nature to do both good and then sometimes cause havoc. And I think disaster recovery is something that's been on a lot of people's minds as we've had hurricanes and as we've had various natural fires and natural disasters around the world. And so one of the other things that's nice about the cloud, and again, is we're basically building in directly into Azure, is we do have DR support. And I'll talk more about how Azure runs all over the world. We have regions, so you can deploy anywhere you want. But above and beyond just having physical data centers that you can use, we also have disaster recovery support, so that both at the application level, the database level, and then also just at the infrastructure level, you can configure your systems so that you can fail over to different regions in an easy way. And so this basically lets you take a VM or a set of VMs, and so you can see in this case here, this VM is running right now in San Antonio, Texas. I can set up a DR rule to another region inside Azure, and now any change to that VM, or again, that cluster of VMs, will be replicated to that other location. And we do things where you can test failover, so you can actually spin up the DR location and do a full set of tests without failing over. It's really useful to know if DR is going to work when you do need it. And then you can also initiate failover with a single command and basically fail over any of your infrastructure to a different location. And this works within Azure, but you can also do it outside Azure. So if you've got, for example, again, VMware or bare metal servers or Hyper-V on premises, you can do the exact same DR kind of model with your existing on-premise infrastructure as well. And again, looking to make that pretty straightforward and easy to take advantage of directly inside of the Azure management experience.
Just a note on that, that works fantastic if you're planning on migrating your on-prem servers into Azure.
Yeah.
We're doing that now.
Yeah, that's a great point. So the gentleman was just mentioning the DR is really useful both for disasters, but it's also frankly really useful when you just want to migrate. And he was sort of talking about how they're using it today, this service, so that they can migrate into Azure. And it's a nice, we're definitely seeing people take advantage of that, where effectively you set up a DR, you test it, and then basically you just fail over from on-prem into the cloud and you never fail back.
It allows us to look back when something's not working.
Yep.
Resolve that, and then we get back to what we're all about, decommission the service.
Absolutely. And specifically, we're also building a new service in Azure called Azure Migrate that's sort of in preview today. And that actually will even do your assessment on-prem. So you can actually look at all your infrastructure and it can pinpoint, here is how to set up the DR, here are the systems that are most likely to want to move, and even give you sizing in terms of the VMs and the configuration in Azure. And then it integrates with our DR story, so you can actually then just install the DR agent, fail over to the cloud, and migrate workloads. So anyways, I'm showing lots of GUI stuff here. The other thing I always like to kind of emphasize is, Azure is not just sort of the cloud for to be managed with GUI. You can also manage it from the command line as well as from PowerShell. And so one of the things you can even do, you can download the tools, obviously. We also then have inside the portal this little button right here, which launches our Cloud Console. When you do that, it basically pops open a browser shell. This is spinning up a VM, in this case here a Linux VM inside Azure. Tried to. Apparently, my account has some issue, but it's working still. This basically gives me a VM inside the cloud that I can then basically go ahead and, if I wanted to, run things in. And it is a full Linux VM. So if I do PS all, I can see all the processes on it. If I want to run something like Vim, I can even do that in the browser inside the management console. You can say like, help, I can't get out. Vim joke. And then you can also go ahead and use the Azure CLI. And so for example here, this is our command line tool that works with Bash. And so I can basically say something like azvm list. Table. And what this will do is actually list for me all of the VMs running in this particular subscription. If I wanted to go detailed on a specific VM, I could say azvm show, and this will dump out all the configuration details about this particular VM in a JSON format, or I could format it to be kind of more of a human readable table format, or I can do comma separate output. And the benefit here is I can pipe things, I can build my own scripts, and I have an environment that feels very friendly and convenient to anyone coming from a Bash shell perspective. And then I can also now toggle it and go into PowerShell mode and instead have a full PowerShell experience just like this. And take advantage of built-in PowerShell commandlets to manage all the resources in Azure as well. And so today I'm going to do lots of stuff with the GUI just because it's a little bit easier to visualize. But know that everything I'm doing today, I can also drive from an automation perspective from Bash, from PowerShell. We also have SDKs for .NET, for Java, for Node, for Python, Ruby, PHP, and soon Go. So I can drive everything else from a programming model perspective as well. And then lastly, if I want to, everything's exposed to a REST API, and so you can always call the REST APIs as well inside Azure. So again, unified way you can manage everything. And then last but not least, I've shown you how you can create or manage resources. Actually, I didn't show you how you create stuff, but you'll see that shortly. You just click the new button and then specify the type of resource you want to create. Last thing that we've been spending a lot of time on within Azure recently, we now have a pretty good story around, is around monitoring. And what I can go ahead and do is take advantage of some of the built-in monitoring support that's now built directly into the experience, and just click monitor on the left-hand side. To basically see all my resources. This is where I can see all the alerts that I'm configured to go ahead and see. I have like 30 subscriptions, so you'll occasionally see an alert pop up about Data Factory. That's not actually a demo I'm doing, but for some reason I am the administrator of that particular resource. And so someone on my team apparently is playing around with another demo and having problems. So I've noticed in the last few hours an alert keeps popping up. Don't worry, that's nothing to do with Azure. It just is more him playing around with it and not realizing that I'm seeing it. And so anyway, this monitor experience here, I can basically set up alerts, and so we'll talk about that this afternoon. This is one of the gentleman's questions around, can you tell us automatically when something happens? You can do that just basically by clicking the alert tab and then saying add activity log alert and wire up rules. We'll show that a little bit later. I can go ahead and for any resource inside Azure, get a metrics view. And so, for example, if I wanted to look at a particular virtual machine, I could go ahead and either see the default views that are shown on the resource blade when it comes up, or I can even go ahead and create custom views for whatever perf counter I want. I'm trying to see if I can find an interesting set of metrics here. There we go. And then again, as I mentioned, you can pin anything to the dashboard. And so if I click pin and then go back to my dashboard here, you'll notice I now have that particular metrics view on my dashboard. And so I can also choose to customize this however I want. So let's make it a little bit smaller. If I wanted to, I could move it around somewhere else. And again, have sort of a tailored, customized view in terms of any of the resources that I'm working on. Who are you able to speak up? Sorry.
Sir, how would these alerts differ from the alerts I set up under log analytics?
So the question is, how are these alerts different than the ones you might set up under log analytics? They're actually the same alert system. So you can basically set them up in either location. And speaking of log analytics, since you mentioned, these sort of metrics are nice because they're easy to create. They, I can basically, click a few meters and have them show up. The other thing we do now support inside our monitor experience is something called log analytics. And so when I click on the log analytics experience, what this is going to go ahead and do is give you the ability to write any custom query against any bit of telemetry that's inside Azure. And basically get a completely custom view on top of any type of data that I might be interested in. So what do I mean by that? So for example, I could use this sort of default simple experience. We also have a cool advanced analytics button that you can click that has a few more extra bells and whistles. And so this is going to load up a custom log analytics viewer here. And what I could basically do is, inside this experience, I'm just going to write a query right now, which is called show me all activity in the last day. And when I run this, that might be hard to see, but you can basically see here, I've got literally thousands of log entries that have been generated both by Azure, which are kind of system level, infrastructure level monitoring, resource created, deleted, modified, resized, had an issue or not. But you can also then take any of your application telemetry And so we have an SDK that we call App Insights that you can add into your application, and it'll take all your application log telemetry as well as any custom events that you want to output, and basically collect it in one place that you can now write queries against. And what's powerful is that ability to mix infrastructure as well as application level details, and to be able to do kind of rich analysis on top of it. So for example, here, I can write a query like so, where basically I'm saying, get all the data over the last 7 days, look at the processor time across all those different servers, and then basically summarize it. So I'm doing an aggregate where I'm averaging the CPU counter by time slot, and I'm basically saying render it as a chart. And so this is this pretty rich language that we support. I hit go. This is not a pre-canned chart, so this is actually doing it in real time across thousands or potentially billions of log entries. And you can see it now is basically automatically generated that chart for me off of my log telemetry. I can do something more advanced. So for example, let's say I want to look at inside these VMs, and this is a sample log. Zoom in so you can see it. This is basically going to take my web server logs, so my HTTP logs, and it's going to basically look at hit counts and then basically bucketize them by browser type. So again, another kind of custom view here, and then basically do an aggregate summary over time. And so now when I run this, I can actually see who's hitting my apps, what type of browser they're hitting, and so forth. You'll notice these queries are pretty instantaneous. That's part of the cool thing about the log analytics system is you can literally write queries that are custom, that basically capture exactly what you care about, and they typically complete in a second or two, or the most a few seconds. And they can run against literally billions or trillions of log entries. Across Microsoft, for running our own internal systems, we generate about 5 petabytes of log data per day, which is a lot of log data. And it all flows through this exact same system that you have access to. And this is sort of fairly indispensable for us actually running our system, and has really been built around that. Last one to show, kind of again, to kind of mention, I've shown you how you can manage infrastructure with this and monitor infrastructure. You can monitor application data. What's really powerful is when you can mix the two. And so, for example, this particular query is looking at a Sharepoint site that happens to be running inside Azure, and it's pulling out the CPU activity of all the machines that this app is running on top of, and then it's pulling out the web server log activity in terms of request activity of the people visiting the site. And it's basically doing a correlation between the two to try to see, are the spikes in CPU because of high rigor load, or are they because of something else? For example, a patch or something that was being applied. Again, I can now run this query against that full data set and get a custom view correlated. And it looks like it's not actually as correlated as I thought. So right here, CPU spiked, but there's no increase in load. This means, hey, maybe I want to go monitor and understand what did change. And I can use change tracking to understand what happened on the system at that particular point in time to better understand it. And again, everything here that you create, you can just go ahead and pin to your dashboard. So if you want to have a query that is very useful for debugging, I can basically pin anything and immediately pull it back. And so when we debug things inside Azure, most of our engineers have like 100 pre-canned reports that they basically just immediately flip through where they already have the query written. And they can very quickly debug and understand exactly what's happening because of that. Yeah?
Is it suitable for taking an action like restarting a server or blocking a port based on a certain condition?
Yeah, so the question is this suitable for taking an action like restarting a server or capturing a log dump? Absolutely. And one of the things that we focused on with our monitoring capability, is now rolled out as of last month, is basically all of our log telemetry is accessible within a minute of it happening. Which sounds not that big, but it really is a lot of work when you're doing petabytes and petabytes of log analysis per day. And so the nice thing is you can basically drive an alert. And so, a common workflow that we see is set up an alert. So we push you when we see something changing, like for example, your CPU spiked or your request went down, or let's say the application response time dipped or increased a certain amount. Fire an alert, and then what your alert might do is automatically run a query to say the detail, and then based on the results of the query, you might decide to restart, you might decide to capture a process dump, or page the right engineer to go take a look at. And so you can build all those types of workflows. And we're not trying to say DevOps is now simple, because it's more than that. But having these tools that you can basically leverage makes it a lot easier to build a kind of nice workflow. And the beauty for all the stuff is you're not having to run any VMs to do it. You're not having to stand up any custom log parsing systems. This is sort of service that you can basically just leverage that's fully integrated with all the apps and the infrastructure that you run. Last thing I'll just mention here, so we've shown lots of stuff inside the Azure portal. We'll come back and we'll do more inside the portal. We also know that sometimes you're not at your machine. And so the other thing that we have done, if we can switch to my iPhone here, is we now have native Azure apps that'll work on your mobile device. So we can switch to the iPhone. Hopefully. And so basically with these native mobile apps, you can basically go ahead and two people with flashlights pulling cables in and out. So, and so with the iPhone, you can go ahead and monitor anything.
It's on the side.
It's on the sides. There we go. Okay, it's on the sides. Is it still on the sides?
Yeah.
Great. And so what you can basically do is, I'm just going to run the Azure app. And so this is a native app that we have. You can pin resources in here, so instead of seeing everything, you often might just want to look at particular apps. So this is my blog image server. I can see how it's doing. I can restart it. I can see notifications. Are there any alerts that are triggered on it? And then, sometimes, hey, I'm at dinner with my family and I get bored. I can click the Cloud Shell, and don't tell them that. But I can, under the table, now I have a bash or PowerShell, and so I can, fire up Vim and or run any custom operation I want across my Azure infrastructure, all under the table. And then when I get caught, I can just close it. And so it does give you, again, you probably wouldn't do your day-to-day administration this way, but it does mean that if you get paged or you hear that there's an issue, it does give you somewhere on the road. And so I can even go ahead and say, so I can say AZ, and there's all the Azure commands. And if I wanted to, I can even go ahead and say Vim, and hey, there's Vim running on my iPhone. This works on Android and Windows phones as well. And so again, it gives you kind of an experience for literally you can manage Azure anywhere that you need it. So now let's switch back to the Windows PC. And we'll keep going.
So, when you use the PowerShell, could you import like the Active Directory module and make changes on your own work AD environment?
So the question is, if you're using the PowerShell on your iPhone, could you import a custom PowerShell module, and could you work on even, say, the AD inside your work environment or your home? The answer is yes, you could. So basically that PowerShell as well as the bash experience is basically a full experience, and it does have a persistent drive. So if you create like a script, so if you're using VI to edit a script and you hit save, it will actually persist it and give you a secure drive that's just to you. And it logs you in as you into Azure. So it's running using your credentials. And so yeah, you can basically import a custom PowerShell and then connect to anything that you have permission to. So by default, you couldn't change your work environment. But if they gave you AD admin privileges and connected to your account, you could. Whether you should change your AD rules while on the road under the table at a restaurant, up to you. But technically, you could make it work if you wanted to. Yeah.
Question.
Yeah.
Some of those expensive log calls that you were making, is that DTU credited? Like you're hitting petabytes of data?
Yeah, so the question is, if that log analytics, how does that work?
Right.
So basically, we provide a bunch of free log analytics that's just included with Azure. And so there's a certain amount of log files that we'll actually store. So things like audit events and standard alerts that we fire, that is sort of included. If you want to dump tons of data, then we have sort of, I think it's a per gigabyte or per terabyte fee that you pay. And that's included in both compute and storage. And it's purely basic on, for us, just the cogs of running it.
So unlimited query as long as you're paying for the storage.
I don't know exactly. If you send me mail, I can definitely get you the exact details on it. I'm not sure if it's unlimited query or there's a certain number of queries to the amount of storage, but it's primarily driven by the amount of log telemetry as opposed to the actual query time. Because we do index on the way in on the logs, and so query is less expensive. But shoot me mail, scott@microsoft.com, and I can hook you up with a team. Generally what we find is for people that have compared us to say Splunk or Sumo or running a custom Kibana or Logstash or Hadoop system for doing logs, that we're significantly less expensive, and it's all integrated, easier to manage. But if you're storing petabytes of logs, it isn't going to be free. But I think you'll find that hopefully the price is better than anything else out there, and be happy to answer specific pricing questions if you send me mail. Okay, cool. So we walked through just kind of the Azure experience. And I showed off lots of infrastructure, mostly because we're not going to talk about infrastructure too much more for the rest of the day, but since a lot of systems either run on top of VMs or some part of the system uses a VM for something custom, I thought it'd be useful to cover still in the developer talk. I'm going to walk through a couple more slides and then we'll dive in and we'll start building some apps and write some code. But just again, for people that are new to Azure, it's about half the audience. Another thing just to point out is Azure runs all over the world, so this is a map of the world. Every one of those white dots represent an Azure region that you can basically deploy code into. And so those VMs that I was managing, I can effectively run them in any of these 42 regions around the world. And we have more countries and regions now than any other cloud provider. And what I thought I'd do is just show a quick video of what these regions look like. I like to joke you can see them from space. They're really big. And we'll play a video and you'll get a sense of just how big they are. That we have the right trust certifications in place so that as you're looking to build applications in the cloud, you can use them in whatever industry that you're in. And so if you are doing anything financially, you need to be PCI compliant, and we're PCI compliant. If you're selling to healthcare, you need to be HIPAA compliant, we're HIPAA compliant. If you are building services that are used by, say, the US Department of Defense, you need to be what's called DISA compliant. And we're DISA level 5 compliant now, which is the highest rating that the US agencies have. In fact, we just announced a couple days ago that you can now even build systems for mission level activities, even if you're selling, say, the intelligence agencies in the United States, which is probably the hardest certification to get. We now have it. And if you're selling pharmaceuticals, you want to be FDA compliant and so forth. And we have more compliant certifications than any other cloud vendor. This just gives you the flexibility to basically build for any market and know that each of these have been independently audited and trusted. And then we now have about 90% of Fortune 500 companies deployed on top of Azure and building solutions on top of it. And this is just a small logo wall of some of them. I'm going to play a video, but I'm going to... Oh, question, yeah? Am I compliant in government portal? Yes, yeah. So yeah, we are government compliant from a gov, in our gov cloud, and so you can basically use us for any government specific scenario, features and services, and start writing some code. The way that Azure is built is we have a whole bunch of infrastructure capabilities, and I talked about some of the general purpose ones in that first demo. And then we have a bunch of higher level services that you can program against as developers. And these kind of provide more of a finished experience, meaning we do things like patching for you, we provide auto scaling capabilities, and so forth, which allows you to kind of focus more on writing code as opposed to having to manage all the infrastructure below it. And we have services for building web apps and mobile apps. We got services for doing data analytics and IoT. We got services for data management and a whole bunch more. And most of the rest of the talk here this morning is we're going to kind of cover a bunch of them and walk through how you can take advantage of them. So the first service I was going to talk about, especially for people that are new, but also people that have used it, I'll talk about some other tips and tricks that a lot of people aren't familiar with, is something we call Azure App Service, which makes it really easy to build and scale apps in the cloud. And you can build web backends, it's great for mobile backends, it's great for API-based backends that you also want to expose. What's cool about it is it provides kind of a full kind of platform as a service model that enables you to run using either a Linux or Windows-based OS container. So you can basically choose which OS you want, and you get the same set of capabilities, including auto patching of all your infrastructure, auto scale, and all the network management, so you can bring up and bring down capacity really easily. And it also has built-in continuous integration and continuous delivery support. And so what we're going to do here is escape again out of PowerPoint and show off some demos of this in action. So we can switch to the Mac now. Let's build our first app and deploy it inside Azure. Yeah, it worked. So I thought what we'd do is, we'll build an app inside Visual Studio with .NET as well. But I mentioned Azure works with every technology. Let's prove it, and let's actually build our first app, not with .NET, but let's pick a different language. In this case here, I was going to pick Node. That works for folks. What do you want to call our application? Red Shirt, okay. Okay, how would we call it Red Shirt Atlanta? Only because the Dallas and the Chicago folks also had that idea. So I'm going to create a directory called Red Shirt Atlanta, and we'll create a new app here. And so I'm just going to say code server.js. It's an empty directory, and code's going to bring up VS Code. You can obviously use whatever tool you want, and tell you what, rather than watching me type in hello world, let me just copy and paste a simple hello world Node.js app that I have on my desktop. And what I can see here is, again, super simple hello world. It's just going to write back hello world. It's listening on the local port 8000. I'm going to hit save. And then what we'll do is we'll just go ahead and say node server.js. So we're running locally. There's no cloud yet involved. And comes back to hello world. So super simple, not terribly exciting yet. What we want to do, obviously, is take this and let's deploy it in the cloud. And so I'm going to go back to the Azure Management Console, and we're going to build a new app. And I could spin up a VM and then deploy it as part of that, but then I'd have to manage, patch the VM, I need to scale the VM, I need to do load balancing and a bunch more. Instead, I'm going to take advantage of this other option called Web App. And we'll call this app about Red Shirt Atlanta. I'm going to put it in what's called a resource group, mainly so that at the end of my tour I can delete it. And I can choose where I want to run it. So I'm just going to run it here in the east coast of the US. And I'm going to hit create. And what this is going to go ahead and do is basically sends a command to Azure and says, go provision a new web app service. Azure is going to basically pull resources and assign it to this particular app. So I can basically deploy code and run it. It's also going to wire up a load balancer in front of it and set up a deployment pipeline that I can use now to publish the app. And basically this is this new Red Shirt Atlanta app that we just built. You can see some of the telemetry data that's starting to populate. Since no one's hit the app yet, it's pretty much, these are going to be empty blades once they load. So let's go ahead and change that. Let's actually deploy the code into this app so that the data is a little bit more interesting. And to do that, I could deploy in a variety of different ways. I could FTP code up and just sort of copy it. Or one of the nice features we have built in is Git support. So I can actually use source control to publish instead. So I'm going to click on deployment options. And then I can say choose source. and I could point to a project on GitHub or Bitbucket or any other code hosting repository out there. In this case here, I'm just going to say local git and click OK. And this basically just configured a Git endpoint on my app that I can copy here from the main dashboard. And then we'll just go back now to my local machine where we got our server.js file in. I'm going to go ahead and initialize Git. I'm going to go ahead and add the files in this directory. I'm going to commit the initial check-in, or say initial check-in. And then I'm going to add a remote in Git called Azure, which will point to that Git endpoint that we just configured for that Redshirt Atlanta app. And now what I can do is I can just say git push Azure master, ask me for my password. And this is now going to push up the code, that server.js file, into Azure. And now, when I click on that URL, it says hello world. And so I basically built an app locally, ran it locally, created an app in Azure, deployed it, and that app, the Node.js app now is running with whatever URL I specified in Azure, basically from scratch.
Scott,
Yeah.
using an app using artificial intelligence, is that simple?
Can I do what's up?
If you're using an app using artificial intelligence, is the process as simple as you just demonstrated?
If I'm using an app using artificial intelligence, I didn't miss the last part.
Is the process as simple as you just demonstrated?
Is the process as simple as I just demonstrated? Pretty much. You'll see a little bit later on. We'll see if we get to it before lunch or immediately after lunch. We'll build, actually no, before lunch we'll do some artificial intelligence-based API calls. And so we'll do face detection, we'll do emotion detection, and we'll also do some textual analysis and sentiment analysis. And basically the only thing that would change here if I was calling one of the Azure APIs is I would basically go into my app here and I basically would just inside JavaScript call a REST API. And so probably 10, 15 lines of code and then take the result. And so yeah, the deployment would be the same into Azure if I was doing that. So yeah, it would be pretty simple. And if I want to make a change, so instead of hello world, let's say hello Atlanta. I can go back to my directory here and just add the change. We'll say commit updated text. And I just say git push Azure master. And this is now just going to take the diff of the code, refresh, and now here's version 2 of the app now deployed. So pretty easy way that I can go ahead and set up a new project. I can git push it and automatically update the code. And if I use NPM dependencies, it'll automatically just work. I don't actually have to push up my NPM dependencies. Azure has the ability to retrieve them. And again, I can deploy this in either a Windows-based app service or a Linux-based app service. So I can basically take advantage of all of the local APIs from whatever my OS of choice. And then a new option that we'll talk about a little bit later that we have with app service is the ability to deploy a Docker container. And so you can also go ahead and actually push up a Docker image that has the environment that you want your app to run inside of. And so if you want to pre-can a Docker image with libraries already pre-installed, you can do that as well for maximum flexibility. Yeah.
Scott, the package, Azure smart enough to know when packages are
Yeah, so the question is Azure smart enough to know when, let's say, a node package is out of date and needs to be refreshed? Yes and no. So basically on every code deployment, we will basically run npm if it's a node out. And so it will pick up the latest dependencies. Now, your particular package.json file that you put in Node, you can lock it down to a specific dependency. And so if you lock something down to a dependency, then we won't retrieve the most recent. I don't know if you lock it down, we probably don't warn you because you've explicitly locked it down. I think there are linting tools that you can run that will warn you. And then by default, we'll pick up the latest version of the package during deployment, which I think is probably the right behavior. We'll see a little bit later on after I show these sort of hello world demos, we'll set up a CI/CD pipeline. And there you can also explicitly add build tasks that will check for version dependency and you can run custom logic as part of your deployment pipeline. So the other thing I'll just mention here before we go on to some more advanced stuff is, and so for example, let me just see, just restart that, probably we'll see now is, you can see the telemetry is starting to come in now for this application. Looks like a few other people in the audience have hit it to prove it's real. 43 of you to be precise, but that's pretty cool. But anyway, you can see I get a whole bunch of the kind of standard diagnostics here. But again, I can always go into that log analytics view and start slicing and dicing the data in an even richer way. These are just the pre-canned diagnostics. Again, I can do really advanced stuff if I want to. The other kind of cool advanced stuff I can take advantage of would be scaling. And so right now this is running on a single instance of Azure App Service. The other thing I could go ahead and do is scale it out to run over more instances. And so for example, right now it's running on kind of effectively one VM in the back end. Again, we manage the VM for you. If I wanted to run on 10, I just hit 10, hit save, and this will now automatically expand this app and deploy it across 10 VMs, and we do all the load balance management for you. Alternatively, since 10 or 1 neither of those might be the perfect answer, instead you can scale it on what's called a metric. And so I can say I want to have between 1 and 10 VMs. So I want to start with 1. And I can basically then say I'm going to add a rule so that anytime the CPU of my front end goes above 70% for some period of time, just automatically start adding VMs up to 10. And then anytime it drops below 30% for some period of time, start removing VMs down to 1. And so that gives you a really nice way that you can set up auto-scale rules so that you only have the capacity that you need. And since you only pay by the second, this gives you a very nice way that you can sort of totally optimize your infrastructure costs to be just what you actually need for your customers to be satisfied. And all this stuff here in terms of the rules all plug into that alerting and that logging system. So anytime something changes, it'll be logged and audited, but you can also set up an alert so that every time we think it needs to change, we can page you or we can send you a message, or you can just see in your Teams room or Slack channel, ooh, we just scaled up or scaled down successfully, and just have a message that your developers, your ops teams can integrate as part of their experience. So super easy way you can scale up and scale down. Question, yeah?
It just multiplies by the number of machines.
So the question is, in this case here, what is the cost? Is it just multiplied by the number of machines? Depends on the service, but for Azure App Service, it basically is the number of instances that you're running. And so as you run more instances, it goes up. All of our compute services in Azure, right now we call it per minute billing. And so we basically just pay for the minute. But the interesting little tidbit is we always round down. So if it's a minute and 40 seconds, we only charge you for a minute. And so it's really kind of like per sub-second billing. We're trying to figure out if we go to per second billing, then unfortunately we raise prices because we round down today. So we're going to probably call it per second billing rounded down. Which is even better than what anyone else provides. And so it means if you run this for 67 seconds on 2 VMs, you're paying only for 60 seconds, and you pay for 2 VMs, and then if it went down to 1, you'd only pay for the 1. And you can also, we'll talk about in the afternoon session, you can now do billing alerts, and we now have full cost management support in Azure, so you can also do budget tracking, as well as budget allocations, and even kind of internal slicing, dicing, and forecasting tools that we just made freely available to all of our Azure customers about 3 weeks ago. It's also demos of that this afternoon. Yeah.
Scaling is the app service point, right?
Yeah, so the nice thing about the scaling thing I should mention, good point, is with app service this, that I'm using right here, you can, we don't charge you per site, we charge you per what's called app service plan. And you can put hundreds of sites into a plan, or you can have just one site in a plan. And so the nice thing here is if you were doing, say, 10 websites, instead of charging the number of instances times 10, basically the difference between one site and 10 sites would be, or apps would be the same. It's just basically, and you can pool all those apps into a common set of resources. And so that ends up being fairly cost effective, because if you're building lots of apps or you're running lots of apps, it doesn't cost anything more to add an app unless it's going to have such high traffic that you need to add more capacity behind it. Yeah. So the question is, in this case here, all the VMs are in the same region. So in other words, I'm running in US East, I think, East 2, so that's in Virginia. And so all these VMs for this app are. There's also the ability where you can stand up, and we do have integrated support inside App Service where you can deploy an app in multiple regions. And so I'll talk a little bit later on when we talk about our Cosmos DB service. You could have, for example, if you're a retailer, you could have an East Coast version and a West Coast version here in the US. And automatically, if a customer is coming from the East Coast, send them to the East Coast version. If they're coming from the West Coast, send them to the West Coast. And we have a service called Traffic Manager inside Azure that will do that automatic geographic split for you. And you can also use it for failover purposes if one of your apps has a problem. Do two more questions, then I'll keep going.
Does the failover and scaling work the same or different if you deploy a Docker container?
So the question is, does the failover and scaling work any differently if you're deployed in a Docker container on Azure App Service versus using this approach? No, it works exactly the same. The only difference with the Docker container, and we'll talk about a little bit later on when we talk about containers, is you create what's called a container registry typically. You put on Docker Hub, or we also have what's called a container registry. And so when you deploy, you actually push the app into the container registry, and then App Service will just pick it up and go. But the scaling and that whole model works just the same. So it's the same nice productivity capabilities. Yeah. How did Azure know it was a Node.js app? Magic. How did it? We actually typically detect it based on certain patterns, and you can also configure it explicitly. And so in this case here, because I had a .js file in my root that was called server.js, we detected it and basically said, oh, this is a Node app, and that's why we run npm. You can also override it if you have a specific policy that you want, but we typically detect .NET, Java, Python, and PHP and Ruby. If you're doing something completely custom, like, hey, I got a C++ extension that I'm somehow running, then you probably go into our options file and just tick custom and what the startup URL is. But we try to make it, again, take some of the administration out and try to make it as easy as we can. Sure, one more question. So the question is there any difference between like a service fabric, which is our microservice framework deployment, and this? There are some differences. So when I get to the container section, I'll talk a little bit more about some of the more microservice-based approaches. And you know, this I'd say deployment model is really, really optimized for web apps as well as kind of front-end experiences, or maybe an API app or a mobile backend. If you're building a microservice that has hundreds of containers with them talking to each other, you're probably going to get into more advanced deployment options where you might want to do flighting and a variety of other coordination and orchestration. And so we support that as well. And I'll talk about that more in the container section. So I'll do that one last question.
So if I'm primarily publishing from Visual Studio and I want some nice handy dandy shell scripts that will automatically start from the lowest level or all the way to the solid state drives and scale it, most customers want you to make the decision for them.
Yeah.
So on build, I'd ask them for their specifics. Where do you want to start and how much do you want to go, how much money you want to spend?
Yeah.
And then my build would execute it. Would you have some scripts of that nature in Visual Studio?
Okay, so yeah, so good question. So I'm showing you here, getting on the command line inside the Mac. Your question was like, hey, how would I do this inside Visual Studio? Can you make this easy there? This is perfect. Thank you for that question. Let's switch over to my Windows PC and let's do that. I'll give you $20 later. This is perfect setup. So yeah, so let's go into Visual Studio and let's walk through, let's say you're building an ASP.NET app. How would you do the same thing here inside Azure? And so the cool thing is inside Visual Studio, we've got lots of tooling support specifically for Azure that makes it really easy to deploy. Right now I just have a standard ASP.NET app. This is an MVC app. It could be web forms, it could be .NET Core, it could be anything. And what we've done inside VS is the latest version, we have a nice publish command. And so you can basically right click on any of those and click publish. And this basically has kind of a nice wizard that walks you through either creating a new app. And so if I click create new, I can do everything I just did in the portal in terms of giving it a name and giving it a size and basically controlling everything. Or if I've already created one in the portal, or already have an app created, I can say select existing. So in this case here, I do actually have an existing one. This is now querying right now my Azure subscription. And so VS will automatically use those REST APIs. And I can basically just go ahead and say, let me take that existing app, click OK. And then VS is downloading what's called a publishing profile with all the details about that site. And then kicking off a build locally. And then it's going to basically push it up into that site and then launch a browser. And I should have about 4, 3, 2, 1. Hello world. So this is just deployed. If I want to make a change, I can go ahead and just say hello Atlanta. Did I misspell it? Oh, I didn't. Okay, good. Okay. Hit publish. And then 5, 4, 3, 2, 1. Now hello Atlanta. So basically I can get the same sort of experience like you saw with Git on the Mac, but now directly inside VS. And we do something similar for Eclipse and IntelliJ, come from a Java background as well. And so our goal here is just how do we make it as convenient as possible from your tool of choice. Now the other thing that we have built into app services is support so that, like how many people have ever deployed an app and found that they had a bug in it? None of you have, but we all know someone who has. And we won't mention any names. But so the classic challenge is you deploy it into production and you find that bug that just didn't happen on your own dev machine. And so one of the things that we also have support for with app service, which is this feature that a lot of people even that are using it today don't know that is there, is something called deployment slots. And this provides a really nice way that when you do deployments, rather than push it live for the whole world to suddenly see, you can actually deploy it in what's called a staging slot that only you test or only a subset of people test. And then once you're ready, you can quickly swap it live. And then you can always swap it back to the previous release if you made a mistake, also really very fast. And so the way this works is you just click on deployment slots with app service. And you can have, I think, any number. I know it's probably a couple hundred slots that you can actually specify. So you notice here I was in Dallas and Chicago. If I want to create an Atlanta staging slot, I can just call it staging/Atlanta. But you can put your app version number in there. You could put, anything you want. It's just a string. And so this is now creating a staging slot. And this is going to be created on the same app service environment. So it doesn't require new VMs, it doesn't cost anything extra. It's just basically through a private DNS entry you can use to basically do final testing of your environment. And now when you go ahead and deploy something inside VS, I can go ahead and deploy it not to production immediately, but instead to that staging slot. And so in this case here, zoom in so you can see. In this case here, I'm going to deploy it to staging. And I'm just going to hit publish. And so, publish. And now zoom in, it says hello Atlanta, and it has tooltip goes away. Tooltip go away. Interesting. There we go. You'll now notice it is got, there we go. It's now scott.gu.usa.net -staging is where that app is deployed to. And just make it sort of easier to see, let me just make one more change to the code. Instead of calling it Atlanta, let's say Atlanta version 2. Like so, let's just redeploy it again real quick. And so I've now deployed an updated version of the app. Notice the version 2, but the URL here again is only in that staging. If I go back to version 1 and hit refresh, you'll notice it still has the older release. So I haven't, people that are visiting my website haven't noticed that I've done a deployment yet, but my code is running now in the same environment that I'll be running in production. I can now do final testing of it. And then when I want users to see it, I can then basically just go back into the portal and I can click the swap button. And I can basically say I want to swap between staging and production. Click OK. This takes about 5 seconds for it to take effect. And so now when I go refresh, version 2 is now what everyone is seeing. And if I go to my staging slot, version 1 has been moved into it. And that gives me a way that if I go like, we made a mistake, I can go back into the portal. And one thing is the portal will pull occasionally to see if the swap's done. So the swap was completed, but we can't swap back until it realizes that it's completed. There, now it knows it's completed. Now I'm going to swap again. And I'm going to swap it back. Hit go. And so this is now sending that swap command. I go back to the main website and hit refresh. It's rolled back to V1. And V2 is back in staging. So a really quick way that you can effectively deploy code, do final testing, swap, and then if you have a problem, you can always swap back. And because you can name the staging slot anything you want, you could have different versions. So you could have version 1, version 2, version 3, version 4 as part of the name. You can, some customers put like a GUID in there so it's unguessable from customers. You can lock it down with ACL so that only your IP address can access the staging slot if you want to make sure you've got some big marketing release you're about to do and you want to make sure it doesn't leak. And then you can also either share the same configuration between them or you can also have slightly different ones. So a customer in Chicago was asking if I have separate ADFS rules for login, can I basically configure the URL differently in them? You can do that as well. So super powerful feature. It's free, doesn't cost anything extra. Definitely recommend taking advantage of because it can dramatically simplify deployment. And it means that when you screw up an app deployment, you can always roll back and not have to worry about redeploying the code and rebuilding it and retesting it. And so it just takes a lot of the angst out of doing code updates and makes them a lot safer and faster to use. Question?
Excuse me, real quick. Since you can use the swap feature, that basically means the name of the slot isn't really representative of what it is. So is there an easy way to actually figure out what is in the slot?
Is there a good way to figure out what's in the slot? Good question. I think there is some metadata you can apply. So you can indicate, this is the code that's deployed in it. You can also, I'm just swapping between staging and production. Some people would swap between, you might have different version numbers and then you can swap it into staging. So there's a variety of ways in the command line or PowerShell you could probably do to kind of automate it further that allow you to keep track if you have lots and lots of different versions. But it's a good question. Probably good feedback. We should probably expose some tagging metadata that you can put in as part of it. The other thing I was going to mention that some people do is for testing, for example, you have SSL certs, or we do this internally inside Microsoft, where we change our internal DNS to actually map to a different endpoint. And so you can basically have your staging version be the thing that like all your internal employees use. And that way you deploy for a day, if they notice anything, you know there's a problem, and then basically just change the public DNS. And that's a way you can kind of effectively flight some set of users ahead of time. We also do have the ability where you can say like send 1% of your external traffic to the staged version. And so that's another technique that we use for app deployments where, you know, we can basically, with 1% of our users, effectively have to be a guinea pig, and then if they have a problem, quickly roll it back. But then if that 1%, the performance is the same, the response time is the same, then we make it 10%, and then we make it 100% of users seeing it. And so all those kind of mechanisms are more advanced scenarios that you can also use with this capability.
If I have the slots as opposed to doing the swap, can I do a push slot?
So the question is, rather than do a swap, can you do a push from one slot to another? I don't know if you can do a push. The nice thing about this is you're not copying anything. It literally is just sort of, we're just changing the DNS entry, which I think is better because that way, if you've got like lots of DLLs or assemblies, or you've got, you know, lots of JavaScript files, you're not waiting for it to copy, and it's atomic.
So here's where I'm going with that. So if I have a dev test process, a deal, I test.
Control system that kicks off a build that can run automated tests and then can push into a staging slot that runs in this environment, which allows you to kind of do kind of the next level of richness in terms of customization here. And so the way we're going to do this is, you know, you can use a variety of different techniques. And so as you saw here, you can just push Git. We have GitHub. We have Bitbucket support. We also have a service that's kind of I think one of the best services we have, and we use it internally very heavily now, called Visual Studio Team Services. And you get all the stuff with your MSDN account or Visual Studio if you have one, but there's also a free tier. And so if you don't have Visual Studio, you don't even have a Windows PC, you can sign up for Visual Studio Team Services. It gives you unlimited free private Git repos, as well as over 4 hours a month of build time for any builds that you do. And it works with Linux, it works with Windows, it works with any language. So it's a great thing to check out. And basically the goal with our VSTS is to have it kind of enable you to build kind of what we call a DevOps pipeline in a really easy way that can enable either you as an individual developer or specifically as you have more people you collaborate with, have a repeatable way that you can sort of manage your projects and move away from deploying directly from your dev machine to instead have an automated pipeline that can do automated checks so that you don't inadvertently check in a bug or check in something that can cause problems. And as part of VSTS, it does a couple things. It does code repositories, so it supports Git as well as TFS as a source control mechanism. And so you can do distributed source control with it. It can then set up automatic build servers for you so that every time you check in code, it'll kick off an automated build in the cloud running on a Linux or Windows VM and compile your code in the cloud. And it also is a test environment where you can basically run any automated unit tests in the cloud after your build completes. And then you can set up a simple rule which says if the test passed, then go ahead and deploy it somewhere. And it could be to a staging slot, it could be to a QA environment, or feeling bold, it could be directly into production. And then it also has support for doing beta testing. So if you're building a mobile app, we have Hockey App integration. Hockey App's now part of Microsoft. It's one of the more popular beta testing tools for iOS and Android apps. And then we also can take analytics and feed it directly back into the development experience. So you can actually see, is my app performing well, is it having errors, and then you can improve. And the goal is, you know, the more automated you can make this, then the faster you can actually deploy code, and the quicker you can actually continue to improve your product because you're getting the data, you can make changes safely, and you can continuously improve. So I mentioned more and more teams at Microsoft are using Visual Studio Team Services. In fact, you know, almost, I'd say 2/3 or 3/4 of our engineers now across the company now have all the projects inside VSTS, including Windows and Office. And Windows is probably the most complicated code base in the world, which is not necessarily a good thing, but we have over 1 million build scripts to build Windows. And on average, it takes, historically, it took about 42 hours to do a clean build of the entire Windows source tree. And so making rapid changes was a problem. We moved it to VSTS, and so all the source code is now inside VSTS. It is sort of almost a terabyte of source code. And so we had to do even changes to how Git backend works, so we pushed back into the open source branch to be able to support that volume of code. And then now with our build servers, we actually with VSTS have about 12,000 build servers for Windows. And so we can now enable our engineers to build Windows clean in about 12 minutes because we basically scaled it out using the cloud. And so going from 42 hours to 12 minutes, there's a lot of developer productivity that comes with that. And so this is an example of a real Microsoft project that's running in VSTS. And so because it's real, I don't promise that you won't see something embarrassing. Since we're going to click on random bugs and work items and we'll see what's in there. But this is the actual Visual Studio Team Services engineering team's dashboard. And so you can see here, you can have a custom dashboard specific for your team where you can track anything that you want to be able to track as part of it. As I mentioned, you can use VSTS just for code. So if you just want to, for example, use it as a code repository, you can do that. And we again support Git, so you can take any Git client. So my Mac Git client works just great with VSTS. It also has full pull request as well as branch visualization capability built in. And so this is, again, this is the live VSTS tree. You can sort of see, zoomed in here, because it's a distributed source control, you can see how all the branches fit together with each check-in and be able to visualize it in a pretty easy way. We also have some pretty nice pull request support. So again, if you're using Git, you're very familiar with pull requests. And so these are pull requests that are active. Here's one that's assigned to me. And you can see basically, for this particular pull request, team members can effectively comment on the code. And we have a sort of a nice interactive way that people can basically do code comments. You can do emojis. And have a very collaborative experience and comments throughout the code as various team members can basically review it before it's either accepted or rejected. And so that's also built into the overall experience. In addition to kind of just source control though, the other thing it does provide is project management, bug item, work tracking, as well as kind of agile planning. And so this is the Kanban board for the VSTS team. With work items and features. And so if I wanted to change the work for Uday, I can just drag and drop it. Since he has no idea I'm doing that, I won't. But again, you can basically, from a Kanban agile planning perspective, implement your sprints and your agile planning and have everyone on the team see it. The other thing you can do with each of these items, and this is sort of where we're trying to integrate some of the process together, is you can also branch and create new Git branches for each of the features or work items that you're working on. And again, that'll tie into the pull request workflow and the source control. And so if you have user stories that you're creating, you can create a Kanban board for them. You can create branches for it. Pull requests can basically merge back in. And again, it provides sort of a nice integrated end-to-end experience that is a little bit more complete than having 5 different tools that you need to integrate separately. And again, this is how we build all our products now at Microsoft, and so you can put 30,000 engineers on a project and it will scale to that level. The other thing you can then do is set up continuous integration servers so that on each check-in you can basically go ahead and kick off a build. And we'll walk through setting that up in just a second. I tried this yesterday and we'll see where we're at. But this is Craig Harry, engineer on the team, has a current build going of some check-in that we can look at. It's been running for 4.4 minutes. And what I've done here is just brought up a web page. And so this is, it looks like a PowerShell, but it really is all inside the browser. And it's just showing the build output from this particular check-in. And so you can monitor across the team all the different builds that are happening. They can happen in parallel. And it'll also then run all the tests once the compilation is complete. And so you can basically create an automated workflow. Every check-in goes through this process, has to run the same tests, and isn't allowed to be checked in unless the tests all pass. And again, you can do this in a completely automated way. And then there's also release management and governance. So you can basically, rather than just sort of deploy into production, you can have an official release management process where you have UAT environments where you might require an architect or a manager to help with the cloud, but you can also debug and test it locally, and it has full CI/CD support that you can integrate as well. So let's go ahead and build some serverless functions and show that out. So you can create a serverless function. You just go new, and you can say Azure function to create one. I'm going to show you an account I already have with a few functions running in it. Windows, we need that anymore. So I'm loading up some functions, in this case here from Europe, which is where I gave the demo last, or built the demo. And I'm going to walk through just kind of a couple of simple scenarios for how you can go ahead and execute those functions and build new ones. So let's just start off with kind of the most basic function, which is let's execute code in response to an HTTP call. And so I'm going to create a new function here, and I can name it whatever I want, and I can also start with whatever template I want. And so I'm going to start off by using what's called an HTTP trigger. And we have a template for C#, we got it for F#, we got it for JavaScript, and a few other languages. And so you can choose kind of the scenario as well as the language. You can also start blank if you want to. I'm going to name it, so we'll call this, how about Atlanta HTTP. Hit create. And if you use our browser-based experience in the Azure portal, we basically have basic editing support that you can take advantage of directly in the console to basically write and test your code. And so here I've got, again, simple function. You can see on the screen there, what it basically does is it's going to execute in response to an HTTP request. It's just pulling a name parameter off the query string and returning it and saying hello name. So not the richest function, but it helps you get started, and it's a nice sort of basic. I can basically just click run, and that will give me kind of an interactive log at the bottom here, as well as a test environment for how I can execute it. I can also just get the function URL. This has sort of a little embedded secret, so no one except me can call it, or anyone I give the code to, I guess, which is all of you. So I hit it right now. You'll notice it just says, please pass a name on the query string or in the request body. If I go ahead and say, and name equals Atlanta. Come back here, it says, hello Atlanta. And if I wanted to test it over here, I could also just go ahead and say, try it here and do, say, an HTTP post. And I can set different HTTP headers if I want to simulate it that way. And again, that provides a simple test environment that I can also use without having to have a separate tool in order to actually try out and test this little function. And what's nice is this function is not running in a VM, it's not running even in an app service or as like a web app. It literally will spin up in Azure when it's called and only executes when I'm actually calling it. And when I'm not calling it, it shuts down. And I literally pay for effectively the clock cycles that it takes to actually execute this function. So if I have an infrequently accessed thing, this is probably the most cost-effective way to run any code in the cloud. Because I literally just pay for the cycles it takes. We've got some customers, as an example, one that does 1 billion function calls per day. They got their bill the first month and they sort of said, hey, that's costing us like $60 or $71. There must be a bug in your billing system. We saw it and said, good God, there must be a bug in our billing system. We did the audit. No, actually, it is $71. And they went, yay, and we went, But it's a good example of how you can use serverless and some of the benefits it gives you. So that's HTTP calls. We can do webhooks. And so there's a nice template when you create one where you can actually say, for example, a generic webhook, which is an API call from another service back to you in response to something. We also even have a template somewhere here, if you scroll down, and there's lots of different templates, for service bus, queues, events, and somewhere in here there's a GitHub one. So here, who here uses GitHub? A lot of people. How many people here use webhooks inside GitHub? Fewer people. Let me turn you into a webhook person. So just create a new GitHub webhook using a function. We have a nice little tutorial on how to do it. And then basically all you do is you get the function URL and you get the GitHub secret. So we even have a nice little place where you can copy and paste the secret. And then basically you just go to GitHub and click on any project you have in GitHub, click on settings, go to webhooks, and then you can basically add a webhook. You got to enter your password. remember your password. There. And then basically just paste in the URL, you paste in that secret, make sure you're doing a JSON post, because the template I think assumes JSON, and then you can basically configure what events do you want GitHub to push you to. And I already have a webhook hooked up to this one right here, and I'm basically saying every time someone opens an issue or comments on an issue, push it to me. So it's super simple to wire up, and now I am, so I'm running this. Make sure I run it. So I'm running this now inside Azure, so it'll show up in my console. I go here, test issue. I could say hello, or new issue in Atlanta. Click comment. Goes to GitHub. GitHub calls that Azure function, and if I come back here, you'll notice it's processed it in Azure, and that's it in the output log. From that Azure function. And right now the function is just dumping it to the output log and returning OK to Twitter. So it's literally, this is 16 lines of code with comments and spaces. And that's all it would take now to wire up an event hook that GitHub calls in response to something. And away you go. And again, the beauty is you can have this, you can create millions of events and issues inside GitHub, and you'd probably pay us like 3 cents a month to run this code. Because it's only running for a few microseconds, and it literally will probably round up to a penny or two, unless you have billions of issues all the time. But we find for a lot of people, their serverless bill is literally a couple pennies a month. You can also then run code in response to triggers for other events. So I showed you sort of HTTP and webhooks. I could also go ahead and use the integrate feature inside serverless. You can also go ahead and add a hook for other things. So in this case here, I'm wiring up a trigger that's going to fire in response to anything being written to a blob container in the Azure storage system. And so the Azure storage system lets you store petabytes. You can put like 5 petabytes in a directory if you want to. And this is just going to say, every time someone writes to my blob, in this particular, or my container here, sorry, every time it runs to a particular storage account, go ahead and run this code. And right now, this code literally just spits out the file name and the length of the file. And so let's go ahead and make sure it's deployed. And then I can go to my file system here, and let's just create this, what do you want to call it, registered Atlanta. Name the file whatever I want. I can go to the Azure File Explorer, which just makes it really easy to upload files and folders to Azure Storage. You can also write code to do this. Oh, there it is. What did I name it? Hit upload. This is uploading the file. Just upload them longer than usual. I'm hoping I didn't just upload my whole desktop. But anyway, refresh. Is it there?
Yeah, it's right
It was there. Okay, great. And then you'll notice when I come back here now in Azure, zoom in the log, it just output registered Atlanta 54 bytes. So again, simple way I can run code in response to something being touched in the file system. Again, I could do it with a service bus queue or an event hub or an IoT event, or pretty much any number of lots and lots of different events that I can sync on. What about, sorry? What about a SharePoint data change? Yes, you can do that too. I'll show you in a second, or not a second, in a couple of minutes, our Logic App integration, and there's a SharePoint connector that does that automatically. And then you can call any number of things, I'll show you later, including an Azure function from that. You can also just directly register the webhook from SharePoint here if you know the right URL. So yeah, you can do it from a SharePoint list change. You can do it from a Salesforce CRM record getting updated. Beauty is you can basically integrate anything. Oh, sorry, question over here. Can you write to the database as part of this? Yeah, and so the beauty is you're running code. So you can basically write to a database, you can do whatever you want. This is your code, it's running in your account. You can pass whatever secrets or connection strings you want, as well as flow it into the app. So let's go ahead and actually show a slightly richer example. So right now I'm just sort of developing in the browser, which is nice, but you know, one of the things that I hear from people is this is great to get started, but the reality is I don't want to like code and hit save in a browser if it's a critical piece of code. I want to be able to use my development tool. I want to be able to check it into source control. I want to maybe set up a CI/CD process. So what you can also do, again, we have tooling with a variety of different tools. It runs on both Mac and Windows. But one of the things we have is inside VS is the ability to say, new project, you click cloud, there is an Azure function option. And this basically gives you IDE support, as well as local development and debugging, all integrated inside Visual Studio. Again, you can do it on a Mac and use different languages as well. But since a lot of people raised their hand here on VS, I thought I'd show that. And so what I'm going to show you here is kind of a fun, weird, quirky little app that I have to confess someone else built, who clearly loves cats, because it's a cat review app. And I don't dislike cats, but at the same time, that probably wouldn't be the scenario I'd naturally gravitate towards. But it's a cool app, so we're going to show it. And where is it? It is, if I open it. Great. And so here's the way this app is going to work. And so this is a Azure Function app. So I just, file a new project. It's not a huge amount of code. It's like 100 lines total, mostly error handling and things like that. And basically I have a function called review image and text that I want to be able to integrate into this reviewers app. And every time someone uploads a picture of a cat with a comment, I want the website to call this function and validate that the picture is indeed of a cat and that the content doesn't have any inappropriate language in it. And the way I'm doing that in this function here is I'm basically just calling this sort of passes image moderation, pass text moderation function, which is calling out to an Azure AI service that will actually do image detection as well as content moderation and basically tell me a score of 0 to 1, how much profanity is being used, and then also what are the different objects that our AI system has recognized in the picture. And so I can just say, if there's no cat in the picture, reject it. If someone uses a bad word, reject it. And the function itself is only a couple lines of code. So I'm going to run it locally. So this is not running in the cloud. This is actually running on my laptop. And so we have a version of the Azure Functions runtime that you can run on both Windows and Mac for local development. It's connecting to the endpoint of this app, which is actually in Europe. So it's going to take a few extra seconds back and forth. But it's running locally here. And I have the debugger loaded. And so now let me go into my browser and bring up the cat reviewer site, which is running in the cloud today, and has a couple different pictures of cats. And so what I can do is I can go ahead and say add picture. I could upload a picture of a cat. I have to use a cat from someone on my team or else they get upset. Or actually, you know what? Sorry, Emily. I need to resize that picture because I learned last time it's like a couple megabytes and then it will take longer. So I'm going to say this cat is so cute. And I'm just going to go ahead and hit create. And what this is doing is it uploaded the picture into Azure, stored it in the storage account. It's now, the storage account is going to send a trigger, which is going to call my moderation function that's running on my local laptop. It just called out to Azure to validate that image and that text. And the place on the breakpoint where I have broken into, or set the breakpoint, I can now check there is a cat in this picture, and the text is appropriate. And so we're going to pass it and make it approved. I'm going to hit continue. It returns. If I go back to my website now, click on reviews, the picture is approved. So very simple workflow of moderation. And now if I upload a picture of, let's say, a dog, and say, oh, such a sweet cat. It's more fun to demo profanity, but it also offends people, so I won't. So in this case here, I'm going to show the dog, and I'm going to basically show it's a sweet cat. And I'm going to try to fake out the system here. And so again, we uploaded it. It's going to fire off the function. We call the AI service. And you'll notice when I look at the text, it passes, sweet cat. Now you look at the image, it fails. This is not a cat. The system says this is a dog. And it's recognized as a dog using our AI algorithm for vision. And so as a result, I'm not going to pass this particular photo. When I go back to reviews, you'll notice the dog's not there. It's in the rejected folder where it belongs because someone didn't approve it correctly. And again, the beauty about all this stuff is I could build this sort of asynchronous validation. I could do things that maybe take, a week to run, or maybe not a week, but take longer to run that are more involved in terms of moderation, but do it all serverlessly. That way I'm not having to run a process on my web server. I don't have to have a VM spinning around, just sitting idle most of the time. Instead, I can just run the code when I need it and have it torn down and pay only for the milliseconds that it's running. And this process probably for even a high volume cat reviewer site is probably going to cost me less than the cost of a latte every month. And so, simple way again that I can go ahead and build serverlessly. And because I'm using Visual Studio here, stop this here. I have IntelliSense, I have debugging, and I can either set up a CI/CD pipeline, or just to get started, I can also go ahead and just hit right-click Publish, like you saw earlier, and I can just deploy it directly into Azure as a new project or in an existing function app that I built, and do direct publish from within the IDE. So it's really easy to get started and play around, and the function stuff's pretty cool, especially once you start integrating with webhooks elsewhere. And so if you're using Dropbox or OneDrive for your family, hey, you can listen on a webhook, you can run code, you can have a folder that if someone sticks a picture you do something with, or you copy files around, etc. It's a pretty easy way. You can do a lot of glue integration. And as I mentioned, that customer that's doing 1 billion events per day, you can scale this thing to a really high level. Earlier on in the beginning of the keynote, you heard Domino's was one of those customers that was talking. They're using this in their ordering pipeline. And so when someone places an order on a mobile phone or a website, they spin up a function to actually process the order and schedule the delivery of the pizza. And that's a nice way, again, that they don't have to have lots of VMs sitting around. If they get 1 million people ordering pizzas during the Super Bowl, they have 1 million functions invoked. If it's in the middle of the night and they only have 10 or 12 in an hour, it's going to cost them less than a penny. Yep. Oh, can I create the functions on a Mac? Yeah, you can do everything there from a Mac as well. Yep. Yeah, so you can definitely publish on the MacBook. There's, I think, 2 ways you can do it. One is we do have like a command line function CLI that you can use for anything. And I believe we also have, if you use VS Code, which is free, and it supports multiple languages, there's also an extension to VS Code that you can use that has sort of VS Code integration. But you can also just use it from the CLI on the command line on Linux or Mac. And that allows you to both locally execute and debug locally as well. Which is one of the nice features where if every time you have to debug something, you got to publish it to the cloud, which is what some of the other serverless options from other cloud providers do. It's a little bit more painful than having it just nicely integrated. So you can definitely do that. And then on your JSON one, in terms of, I think when you republish it, will republish everything, but shoot me mail if there's a specific case, and happy to put you in touch with the functions team if you're looking to kind of omit a file. There might be a trick that I don't know how to do that off the top of my head. Yeah. So your question is, I don't know much about serverless, but it seems like this might cannibalize other parts of your business. That's sort of sounds like my CFO. But generally what we find, and kind of our philosophy with Azure is, A, I'd much rather cannibalize my business than someone else cannibalize my business. And B, generally what we find is as people actually learn all these great features and find ways to save more money, what ends up happening is you build better apps, and that grows your business, in which case you build more apps. And so we benefit in some way, shape, or form too. I was talking to someone in the break, and I said, "God, this SQL managed instance thing you showed me seems almost too good to be true." I hope it is. That's certainly our goal. And it is going to save money on a per database front from what you have today. Hopefully, and what I'm hearing more and more from companies is people saying, look, I'm not going to increase the IT budget or anyone's budget, but if you can find ways to save money, I'd love you to reinvest it and build more systems. And as more companies become more digital and are using systems to talk to their customers more, you'll end up building more apps. And so I think there's hopefully a win-win for everyone where, for serverless, there'll be lots of places where people will be able to turn off VMs that they're running today. But as you get more value out of the systems you build, you'll probably also build more systems. And that'll be good for you, and hopefully it'll be good for us. Yeah.
Does the function support IOC container out of the box?
Does it support IOC?
Container.
Yeah. Okay. So a version of control
Yes.
containers.
So
Yeah.
it's kind of if you already have a custom assembly.
Good question. So the question, can you support IOC containers? I don't know off the top of my head. I believe so. We use some of the same. Let me show off some more stuff. So we showed off Azure Functions with serverless. Let me show you another way to do serverless that I think is pretty cool. And it's one of these sort of hidden services inside Azure that once people know about, they go, oh my gosh, I had no idea that you had. And it's called Logic Apps. This basically is another way to run serverless code, but instead of having it be a very code-centric approach, this is basically a workflow that you can define that can have any number of connectors that can reach out to, I think we're up to about 170 or 190 different data sources and other apps pre-built in that are easy to wire up and call. And what's nice about Logic Apps is you can also have, there's a Azure Functions connector. So you can basically build a workflow and call out to any of your own serverless functions that you want to build using the approach we just showed and write imperative code. But the nice thing with Logic Apps is being able to use some of these built-in connectors makes it super easy to do a lot of integration scenarios as well as handle long-lived things. So someone asked about Sharepoint as an example. Logic Apps, you could certainly do it with Azure Functions, but I think you'll find with Logic Apps, it's even easier to take advantage of. And so you basically just say new Logic App, and you can use the Logic App Designer inside the portal. There's also tooling support inside VS to basically construct and build any Logic App workflow you want. So here's a simple example of one where I'm going to basically listen on Twitter. So there's a built-in Twitter connector, and I want to basically check every 15 seconds for any tweet that has the word Azure in it. And so I'm just going to basically pull that data in to kick off the workflow. And then when I pull a tweet, I'm going to call out to the sentiment analysis connector that's built in that calls an Azure AI service. And so remember we did image detection and we did profanity checking in that last cat moderation app. This one is a sentiment analysis that'll basically return between 0 and 1 as to whether or not the person is happy or sad in this tweet. And tweets are sometimes hard because there's only a certain number of characters, but you could use this with a document or a call log if someone complains on your website to see how upset they are, and this will basically tell you. We then are pulling out key phrases, and so we can sort of categorize automatically using AI what are people talking about. This is a place where we're calling an Azure function, a custom function, and doing some processing. And then I'm pumping it into a Power BI data set. And so this is going to basically give me a way, as this workflow is running, that I can see in real time in a BI dashboard what are people saying about Azure and visualize where in the world they're actually doing it. And then I have a simple if statement, which basically says if the score of the sentiment is less than 0.3, meaning we think the person's unhappy, basically pump it into a Teams room that my team can monitor. It could be a Slack channel. We have a built-in connector for Slack as well. And then also open up a support case in Dynamics 365 CRM. I can also put it into Salesforce. And basically all this stuff I can kind of build graphically with these conditions. If I wanted to add other connectors, we've got literally, as I mentioned, it's either 170 or 190 or somewhere around there, built-in connectors. And so we have a SharePoint connector. We've got SAP connectors. We've got connectors for all Azure resources. We've got Box. We've got Salesforce. We've got Amazon. We've got IBM DB2. We've got Oracle, Dynamics, Google, Informix, MailChimp, you name it. There's lots and lots and lots and lots. And they work both in the cloud, and they can even reach back to your on-premises environment if you open up. There's a gateway that allows you to connect to on-prem systems. And the beauty is you can also build your own connector. So if you have an existing system, put an API in front of it, build a connector, and it can now show up, and you can drag and drop it and build custom workflows. So let's go ahead and look at what this looks like. So I mentioned this is pulling from Twitter. I also warned this is pulling from Twitter. So we're running, I'm never quite sure what's going to happen. You can see here, this is real data. Funny enough, I once gave this talk in Australia, and there's this thing called the Azure Cliff, or Azure, it's in Malta, and it's very famous, and it collapsed and fell in, and everyone's sad. And the sentiment like went off the chart negative. I'm like, whoa, what's going on? And then you read the tweets and it's like, oh, it's so sad it collapsed. And it was all about this other Azure thing. So that's the other thing you gotta be careful of is sometimes there are other things besides a cloud provider called Azure. But you can see on average, the sentiment, or maybe you can't see, but in general, the sentiment is pretty high. So the average score was 0.97, that's actually exceptionally high. But there's a few outliers. And so what I wanna be able to do is understand people that we think the tweets might be negative, what are they? And again, you can sort of see the map is updating in real time for where all the tweets are, and you can see the key phrases that we're kind of extracting. This is the most interesting one. Jim Bugwadia, super. Tonight, great vibe, VMware code, Kubernetes Azure. Well, anyway, so someone thought that was great, as Jim did, and so forth. And I can basically then open up my Teams room. Again, this would work with Slack or any other communication mechanism that you use. And this is now, remember, going to show all the negative tweets or the things that the AI algorithm thought might be negative and pump it out here. And again, it's Twitter, so in 140 characters, some things are actually not as negative as you might think. But you can see here, for example, this negative tweet is, let's see, where is this one? You know, the biggest pitfalls to avoid when adopting cloud. Know why cloud strategies fail. So anyway, seems like a negative tweet, which is why it basically shows up. There's other ones here. What kind of disaster recovery plan does your business have? Well, that's not really a negative tweet. Oh, here we go. I always dislike seeing myself on the screen, but want to spread the word, maybe someone here. Anyway, so but you basically see it's a simple workflow, and now we can kind of monitor what's going on, what people are saying, and go ahead and track it. In addition to kind of building this thing, I can also then see it running, and so I can see all of the tweets that have happened in the last few minutes, or hours or days, and I can even go ahead and debug any of them. And so this is a tweet that came in, and again, I apologize, I have no idea what it's going to say. It says, hopefully something nice, here, applying Azure ML in software development. So someone tweeted it, there's the details of it on Twitter. You can see the sentiment came back as 0.5, meaning neutral. The AI algorithm didn't think it was negative or positive. Here are the key phrases that were pulled out: Azure software development retreat. And then you can see we added it to the data set. Because it was 0.5, it wasn't considered negative, which means we didn't push it into the team room or inside our CRM system for support to follow up. And so it's sort of a simple way you can kind of debug and post-analyze any of these things that are happening. So, simple way you can run logic apps. Again, great for data integration. That SharePoint scenario, just plug in a connector. Every time a list changes in SharePoint, run a workflow. And again, you can add your own custom code into this workflow as an Azure function. And again, this doesn't cost much to run at all. And you can scale this thing to literally billions of events if you need it. So, keep moving on here. And I mentioned Domino's with their order deliveries using it today. So, there's a nice way you can upload pictures to train. And so I'm just going to go, and this is pulling from Bing. So these are pictures of me. He's not me. There's like a hipster version that also isn't me. And there's someone who's in jail, and that also isn't me. Or looks like they are. But none of these pictures I'm selecting are that recent. So none of these are like taken this morning or taken like when I was setting up this demo. The newest one is probably 3 years old. And so I'm just going to basically upload them though and tell it, this is Scott Guthrie. And you'll notice now when I'm running this, instead of just saying it's a male, it actually is automatically detecting who I am. And then it gives me in the parentheses the rough approximation of how confident it is this is who I am. And so you see right now it's 60%. If I move in or move out, it might be able to do a little bit more accurate detection depending on the light. And again, it's only as good as the data you train it on. But this sort of gives you kind of, again, very basic image person detection capability. And so next time you use Facebook and you upload a picture and it identifies the people, it's using an algorithm just like this. And you can now add this into your own apps. And again, there's no VMs, it's all effectively a service. You're not having to manage the infrastructure behind it. And so there's lots of other cool scenarios that you can do with just the built-in APIs. And again, the beauty is you can call them from anything. You can even call them directly from a mobile app without even having to go through a middle tier inside Azure. Or you can call it from your backend inside Azure and connect to it that way. In addition to having the built-in APIs, we also then have an Azure machine learning service that's super powerful. And this is intended for data scientists. And it really enables you to take your own custom data and build AI models and algorithms around. And this works both on the back end with what we call the Azure Machine Learning Service. And then we also have a new Azure Machine Learning Workbench, which runs on your local machine. It runs on both Windows and Mac. So it's cross-platform. And it basically provides a bunch of tools that enable you to work faster as a data scientist building your own apps and algorithms. It includes data wrangling tools, so you can take data in any random format and clean it so that you can actually start doing AI against it. And if you talk to a data scientist today, they'd say about 80% of their time is actually just trying to get the data in a clean format so that they can actually use it. This tool makes it easier. You can use whatever AI framework you want, whether it's something like Spark or TensorFlow or Cognitive Toolkit or Cafe2 or Keras. You can do it, and we integrate Jupyter Notebooks, which is an open source project that makes it really easy to visualize and work with AI algorithms and run them interactively. And the beauty with our Azure Machine Learning Service is the output is a container, and you can run that container anywhere that Docker runs. So you can run it inside our container service, you can run it theoretically inside Azure App Service or our batch service or anywhere inside Azure. You can even deploy and run it on a different cloud or in your on-premises environment as well. So it gives you kind of maximum flexibility. And so what I'm going to do is invite Seth on stage here to show off a quick demo of Azure App Service in action. Hopefully it'll go somewhat fast since we have a total of 18 minutes left to finish the talk. I have a whole extra 3 hours of content.
I'm going to make you a data scientist in 3 minutes, so you'll be able to get a raise.
It'll be that fast, but yeah.
Not that fast, okay. Okay, my name is Seth. I work at Channel 9. I'm also a cloud developer advocate. I work with AI, ML, and emerging technologies, which sounds really fancy, right? And so I'm pretty excited. How many of you do data science? Okay. So I will tell you the dirty secret about data science. Anybody work at a bank? Okay. That, like if you work in a database system at a bank, it's kind of like dirty jobs. You know what I'm saying? Is for as much as you try to get Bill to put the age in the age field, he always puts it in the name field, right? And so the thing about data science is being able to extract data from messiness. And so when Scott said 80% of data scientist's job is literally cleaning up data, he means it. Okay, so it looks like they got that up on the screen. So let's pretend you have a company and you make chips. And so what you do is you have someone sitting there and they have to go through and they say, yeah, that chip looks like it's good. And then they go to the next one, they say, yeah, that one doesn't work. Now you want to build a program to do that. Right? In our heads, what we're thinking is, what series of steps do I need to do in order to make a program that will solve this problem for me? You want to have some magic function, let's call it H, where you pass in this picture and it sends out pass or fail. In your head, right now, you're trying to figure out, like some of you are literally right now thinking, well, if the middle is yellow, it's not, you know what I'm saying? You are all thinking that. Machine learning is not that. Machine learning and data science is quite different. Instead of thinking about a function that you write, think about a function that your computer writes for you. Instead of giving it a series of steps, you give it a series of examples of pass or fail. And then what the computer does is it writes this magical function H for you. It's not really that magical. So let's talk about the process. You always got to start with a question. The question is, can we predict whether or not these chips pass or fail inspection? Then you got to go with your data. So this is our data right here. And remember how we talked about dirty jobs? This is your data. It's a picture. How do you know whether or not something passed or failed? Well, you look at this picture and you're like, oh geez. Some of you right now are really like, are my nerd, you know, spirit animals. You're literally thinking of regular expressions. Who's doing that right now? Don't do it. Don't do it. Don't do it. Because we have something called Azure Machine Learning Workbench, which is now going to help make that, where's my mouse? There it is. Do you ever lose your mouse? It's pretty scary, especially when your boss is watching you do like a demo. Okay, so what we're going to do is you have, see, Azure Machine Learning Workbench is open here. It's a combination of Azure services and tools for machine learning with dev GUIs and command line support. I've said what marketing told me to. Notice that if we go over here, we have the image path and we have the board ID that we got from that comma delimited file. Remember, we had to get this thing called pass or fail, all right? So let me show you how to do that. I'm going to right click, and there is this button. I'm going to make sure you can see it. That says derived column by example. I'm going to click on that, and I'm going to say derived column by example, and now I am just going to tell it. So this one right here looks like a pass, so I will type in pass. This one right here looks like a fail. It got that one right. This one right here looks like a fail. This one right here looks like a pass. It looks like, because I did this before to test it, the ones with parentheses, it even learned how to do that. But the thing about this code, right, or this that I just did, where I extracted this column by example, is we are actually writing code behind the scenes, so that you don't have to write the kind of code that makes you not be able to look at your spouse at night. You know, the code you've written where you feel like you have to take a shower, where you've changed a 0.7 to a 0.9 and it works and you don't tell anybody, and you have a secret shame. Let that be our secret shame now. Now we can write the code here that will allow you to extract the actual label that you want to do. Once you do that, once you've cleaned up your data, then you got to start building the model. Python is probably one of the most popular tools for doing data science. Python is a wonderful programming language. Notice here I have something open called Jupyter Notebooks, which allows you to do experimentation. So look, you just literally type code in, and then you press Shift Enter, and it runs. And I know it's probably hard to see, so I'm going to zoom in here. This is like regular Python. And if you have not learned Python, that's okay. I figured it out in a little under 2 weeks. No, I'm just kidding. I actually use Python in school. So notice I go here, and I hit this, and notice that everything is going to run. Now, while it's running, the other thing that's interesting is that you can run this in the context of whatever you want. So this one's running, actually can be run on something like a huge GPU. If you saw Scott's demo where he showed a huge computer, you can run these things in the context of ginormous computers. That's the technical term that we use in Microsoft. Notice that right here it's going to predict this.